In this section, we're going to talk about degrees, minutes, and seconds. Well, degrees, minutes, and seconds are one of the oldest formats for geographic coordinates. In fact, they go back to the Babylonians who worked on a base 60 number system. And you can see in this old image, Cape Hatteras Lighthouse, which was erected in AD 1870, has a latitude and a longitude in degrees. We can see the 35 degrees and the 75 degrees. And then the remaining coordinates are in minutes and seconds. In this example, let's do some definitions here. Each degree contains 60 minutes. So we're going to put some math language here. Each degree, we're going to say each 1 degree is 60 minutes. So 1 degree is equal to 60, and then this little mark, this little hash mark above the 60, that represents minutes. Each minute, so each 1 minute, contains 60 seconds. So 1 minute is equal to 60 with now 2 hash marks above it. So we know degrees to minutes, we know minutes to seconds. The last one here that maybe we want to define is degrees to seconds. So each degree, we know that a degree is 1 with the little circle notation above it. And each 1 degree contains 3,600 seconds. So let's try an example. In this example, we're going to convert from DMS, and you'll notice in the title of this section that DMS stands for degrees, minutes, seconds. It's just a little bit of a faster way to say it. And we want to convert from DMS to all decimal degrees, so no minutes and seconds. What that means is that we possibly are going to have a partial decimal degree that we have to round. All right, so let's use that lighthouse example, and we're looking at the latitude that has 35 degrees, 15 minutes, and 14 seconds. And we want to convert that to decimal degrees. So I'm going to start out always with writing the original problem, so pay attention to this notation. It'll help keep you organized, and it'll also help the reader really follow your work. So 35 degrees, 15 minutes, 14 seconds. What that represents is 35 degrees plus 15 minutes plus 14 seconds. Okay, so what I want to do, and you'll notice I put some space there, I want to convert those minutes, the 15 minutes, I want to convert those to degrees. So I'm going to use this first conversion factor of 1 degree equals 60 minutes. I'm going to multiply that by 1 degree over 60 minutes. Now the reason why I choose this way to do it is because notice on the top the minutes are there, and now on the bottom the minutes are there. Those units are going to cancel each other out, and I'll be left with just degrees, which is what I wanted. For the 14 seconds, I need to convert from seconds into degrees, and so I'm going to use the conversion that 1 degree is 3,600 seconds, and I'm going to multiply by that. 1 degree on the top, 3,600 seconds on the bottom. And I'm picking this route because the seconds on the top and the seconds on the bottom will cancel. So sometimes you'll see me write, for example, 1 degree on the top in the numerator. Sometimes the 1 degree will be in the bottom in the denominator. It really just depends on what I want to cancel out. Now, what I'm going to put in my calculator is 35 plus 15 over 60 plus 14 over 3,600. And that's going to get me the decimal approximation of 35.2538889, which, because I'm going to round to 4 decimal places, I'm going to look at that 4th decimal, which was an 8, and the number that's next to it tells me that that 8 is going to turn to a 9. So this becomes 35.2538889. 2539 degrees approximately. Let's try another example. In this example, we're going to convert from decimal degrees to degrees, minutes, seconds. So convert the latitude of Portland, Oregon, which is 45.523064 degrees, convert that into degrees, minutes, seconds. Okay, so let me write down the original problem. So I'm going to have 45.523064 degrees, and what does that equal? So that equals 45 total degrees plus the decimal amount of 0.523064 degrees. And I need to get rid of the degrees, and I need to get minutes. I need to, let's see here, I need degrees and minutes. So that is going to be this conversion. And I'm going to multiply it by 1 degree now down in the denominator because I want the degrees to cancel, and 60 minutes up in the numerator. All right, so the degrees cancel out. And when I multiply that, I'm going to get, let's see if I can get this in here, I'm going to get 45 degrees plus 31.38, looking at my calculator, 384, and that's minutes, all right, because the degrees up on the top and the degrees on the bottom cancel out, and so I'm just left with minutes. Okay, so let's keep going. I'm happy with the 45 degrees. I'm happy with the 31 minutes, but I want to take care of that partial minute, which was 0.38384. I want to multiply that by something that gets rid of the minutes and gets me seconds. And so that's going to be this second conversion, that 1 minute is equal to 60 seconds. So I'm going to multiply with 1 minute in the denominator and 60 seconds in the numerator. All right, when I put that into my calculator, I get, let's see here, I got the 45 degrees, I'll rewrite that. I've got the 31 minutes, and I got, if I put that into my calculator, I get 23.0304 seconds. And that, again, is because the minutes on the top and the minutes on the bottom canceled out. Now this one said to round to the nearest second if necessary. So I'm going to say that this is approximately equal to 45 degrees, 31 minutes, and 23 seconds. That is rounding to the nearest second. Make sure that you follow this notation, even if you're getting the right answer. If you've got work all over the place, if you have partial steps all over the place, it's really hard to follow. And the equal sign that you see me using, that equal sign really means that what came before it equals what follows it. So it's an important notation to follow.